All right, session 10, let's go. And welcome back everybody. If this is your first time, you picked a generally great week to show up. Tonight's topic is one of those where experienced devs will be like, "Yeah, I know this." And then learn three things. And then we will learn three things that you didn't know. So stick around. Um, Before we get into it, you know, the week's been pretty good. It looks like I actually don't have anybody that showed up tonight, which is totally okay. We're just going to proceed and hopefully people join in throughout it. Otherwise, we're going to at least have the recording to go up on YouTube so everybody's able to catch up. I know life hits hard. I've been absolutely getting slammed with it. Getting back into the gym, trying to get back on a diet and things like that. So I know, just finishing up this move as well. So everybody gets hit hard, so no worries. We're just going to keep chugging along and we're going to keep doing this each and every week. So here's where I want to start tonight, though. We're going to think about the last time we wrote any real JavaScript. Doesn't really matter what it was, a component, route handler, utility, function, whatever. I guarantee that within the 5 lines, you either created an array or accessed an object, or both. Arrays and objects are the shape of data in JavaScript. Every API response you'll ever work with, every piece of state in the React app, um, every database document, it's all array objects nested inside each other in different configurations. Um, Here, I want to make sure, just in case someone does join, we can at least, nope, not that one. We at least have our screen on for them to see. So yeah, let's see where arrays and objects, yeah, are the shape of data in JavaScript. Every API response we work with every piece. Yeah, we already did that. All right. We use them constantly, but most people are only using a fraction of what they can actually do. Tonight we're going to fix some of that, and we're just going to dive straight into it. So arrays and objects, when to reach for which. Um, First things first, what's the actual difference and when do you use each one? Arrays are ordered lists. The order matters. You access those items by their position, their index. Um, let's see, just seeing what's on the screen. Use an array when you have a collection of things, or order matters, and when you're going to loop over them. And then you have objects. Objects are labeled containers. You access values by their key, their name. Use an object when you have a thing with properties. Each piece of data has a specific meaning, and you want to look things up by name rather than position. Um, Here's the practical test. Let's see. Ooh, perfect. Um, Here's a good practical test that I run in my head when I'm deciding, is this a list thing or is this one thing with multiple properties? A list of users. Let's see what else we got. Yep, perfect. Um, a list of users, an array. One user with a name, um, one user with a name, role, and streak. Object. A list of messages, array. One message with a sender, body, and timestamp. Object. Um, and they nest because real data is almost always a combination of both. So yeah, like a list of users would be an array, one user with a name, role, and the streak object. A list of messages would be an array, one message with a sender, body, and timestamp, an object. Just to go over those again. So the pattern here, an array of objects, is what you'll work with constantly. And we're going to come back to that here in a bit. So I'll pop over to destructuring. Destructuring. All right, so destructuring is one of those features where once you start using it, you can't go back. It's ES6 syntax for pulling values out of arrays and objects cleanly, instead of writing out the dot chain to every time. Let's see. Object destructuring. Here we go. So this is the old way of doing it. This is the newer way of doing it. So when you destructure, right, you're telling JavaScript, pull these named properties out and give me variables for each one. You can typically also, you can rename them while you're also destructuring, and also set defaults. This is big and huge in React. Every time you write a function, like my component, let me see. Yeah. Array destructuring. Let's see. Yeah, so every time you write a function like my component with like title, onClick, and children, that's destructuring the props object right in the parameter list. I'm trying to see where I had, yeah, right here, some extra powers. So, pulling like usernames, streaks. I hate that sometimes my slides don't match my notes. Let me fix that. Array destructuring. Same idea, but positional instead of named. You can skip items with a comma and swap variables without a temp variable. A classic interview trick where you'll see an array destructuring most in the real world, like useState. This. That's literally array destructuring. useState returns an array with two items, the state value and the setter. You destructure them right there on that line. Now you know exactly what's happening under the hood. A good thing for like a good question that interviewers might even ask is explain what destructuring is, and you could simply say it's a syntax for extracting values from arrays or objects into distinct variables. That's pretty clean, simple, and memorable. Perfect. Spread and rest. Some water. Spread and rest use the same dot syntax, but they do opposite things depending on where you use them. So rest, we touched on this a little bit last week with rest parameters. It gathers things together. Spread, it spreads things out. And we're going to look a little bit at some of this hopefully in action. Here we go. Copying an array without mutations. So without a spread, like const copy original, here we go. Const copy original just gives you another reference to the same array. You mutate one, you mutate both. Spread gives you actual independent copy. So like merging arrays. Your const front end and back end. Const stack, things like that. Copying an object. The spread happens first, then the role. Super admin. So where we at? I hate that mo. Oh, here. The spread happens first, then role. Super admin overwrites the old rule. This is how you update a single property without mutating the original. A pattern you'll use constantly in React state updates. You're spreading all existing properties, then overriding just the one you want to change. Everything else stays the same. On our like WTWR apps that we did, our weather apps, every time we update user preferences, it was this exact pattern. Spread the existing state, override the changed key, done. That's pretty much it. There we go. All right, moving on to array methods that actually matter. Okay, so this one, everyone should bookmark. We're going through an array method you'll actually use in production, not just what they do, but when and why. We already know map and filter and reduce from last session. Tonight we're adding to the toolkit. So let's see. So with map, transform every item, return a new array of the same length. Filter, keep only items that pass a test, return a shorter array. Or reduce, accumulate all items into a single value. Now that's one that people sleep on. And not that one, the one that we moved. The one that people typically sleep on is find. It returns the first item that matches. Let's see. There we go. The first item that matches, not an array, the actual item. So you typically want to use this when you need one specific item from a list, looking up a username by ID, finding a product by a slug, getting a session by token, all find. Some and every, those return booleans. Some is, does it at least match? Every is, do all of them match? Useful for validation, permission checks, form states. We also have flat and flat map for nested arrays. Flat map is map then flat in one step. Useful when you're transforming. Useful for when you transform. It's useful when your transform produces arrays. You're able to get them a lot nested and a lot more settled. Then we have chaining. Then you have chaining. This is a real power move here. Each method returns a new array, so when you can chain them indefinitely. Filter, map, reduce, whatever shape of this shape of the problem is. A good interview call out would be like, what's the difference between map and for each? Map returns a new array, for each returns nothing. It's purely a side effect loop. If you need a result, use map. If you're just doing something with each item, logging, updating DOM for each. Pretty easy, pretty simple. Next, we will bop on over into nested data. So, real API data is never flat. It's always nested. Objects inside arrays, arrays inside objects, objects inside objects. So we're going to build, so let's build the muscle for navigating some of it. Oof. So accessing deeply nested values, destructuring nested values, accessing, destructuring, mapping over nested arrays, filtering on nested properties, getting all names from the arrays, getting users who have notifications on, because if they have notifications, you want to make sure you're targeting the right people. The pattern here is always the same. Drill down to the array you need, then apply your methods. If you're ever lost in a nested structure, console log each step until you can see the shape. Console log is your best friend. Just always remember to remove it when you submit your final products. Then you have optional chaining, the safety net for nested data that might not exist. You'll use this every time you're working with API data that might be incomplete or loading. So it's always good to know. Object shorthand, computed keys, and immutability. So let's see. So 3 quick but important patterns before the refactor, right? So object shorthand. When your variable name matches the key name, you don't have to repeat yourself. You write this constantly whenever you're building an object from existing variables. Shorthand keeps it clean. You have computed property keys. You'll write these property keys when you need a dynamic key, one that's determined at runtime. Useful in form handlers, dynamic config objects, anywhere the key name isn't known until the code runs. Then you have your immutability. Ooh, someone join up? Hey, what's up, brother? Coming close to the end here, but we do have a couple games afterwards if you're about it. I'm gonna keep running it though. Yeah, immutability. This is one pattern. This one matters more than it sounds, especially in React. Don't mutate your data directly. Instead, create a new version with the change applied. Let's see. Here's a good some representations. And why does it matter? React uses reference comparison to decide if it needs to re-render. If you need to mutate an object in place, React looks at it and sees the same reference. Nothing changed. Your UI doesn't update. Immutable updates create a new reference. React sees the change, re-renders, and that's the whole thing. What matters? Here's the slide for everyone to pause on things. And then a nice little real world refactor. We're gonna tie everything together, same format as last week: messy in code, clean code out, or messy code in, clean code out. So imagine you get this raw API response and you need to build a leaderboard from it. You need only active users. Only those can score 70 plus. Sorted highest to lowest, returning just username and score. Without the tools we covered tonight, this is a mess of loops and if statements, but with them, we're able to clean it up nice and perfect. And we're going to break this down as to what happened here. So your dot filter UI, UI active right here. This is drop. So this is to drop inactive users. This right here is to drop low scores below 70. This is to get highest first. And this allows the destructure inside the map and then return only what we need. So every single concept from tonight in one chain. This is the pattern you write when you're working with real data and real code bases. And that's it. That is the content for today. We do have a couple games if you want to go through them, Brandon. I was probably going to probably just click through them since I was by myself, but if you want to, since you're here now, up to you. Oh, looks like they left. I guess they'll probably rewatch the stream later. Yeah, let's click through some of these questions. So what does this return? So admin dev, we need user one name. So we know that arrays start at 0, so it will return Zaya. I like how she worked it with me in one of my projects, and I possibly might be helping her with her and her boyfriend's project, Dylan. But like, just keeps using their names. I need to get some new names in here. What gets logged? Let's see. So we have a user. This looks like an object, each with properties. It looks like we're destructuring here for the user. So we're saying the user should equal the name and the streak. And we want to log the name and streak. So I would think it would be ooh, we are right. What does this return? Const nums, array 1 through 5. Okay. Const result, nums filter. All right. Let's see. So this is saying that we want to have even numbers. So boom. So this is a remainder, and since we're dividing by 2, if you divide even numbers by 2, obviously they will have a remainder of 0. Whereas with odd numbers like last week, they would return a remainder, like with off of 3 divided by 2 would be 1.5, so that would be 0.5, which would not equal 0. Boom. What is the difference between these two lines? Ooh, okay. A equals original, B equals ... original. I don't like how all the answers are B. I'm not liking that. I gotta do something about that as well. I'm pretty sure I said something about that last week as well. I need to make a note. I'm sorry, everybody. But yes, B is an independent copy because the spread will give you an independent copy. Alrighty. What gets logged? So this is an array of objects, it looks like. Const found equals users.find. We want to find anybody with ID of 2. So constant log, it should be, yep, Saya. What does this return? User equals object const update equals ... user. So this will be now an independent copy with now the role of admin. So it looks like it would then be actually maybe. See, there it is. As we're creating its own independent copy for updated, and then we are changing the role to admin from dev. What gets logged? So scores is an array where we want to console log 2 different things. The first one is saying scores dot sum, so it doesn't have to match every single one. So S is greater than 90. It would return true because there's one that would be greater than 90. And then console log scores every, so all of them have to meet this standard. So S to S would be over 50, and that would then return false because 40 is below 50. Alrighty, what does this return? Const first, third equals ABC. Okay, first and third. Well, if we're only logging first and third, I'm gonna say B. Okay, yeah. Is positional. That's what I like to say. It's positional. The double comma skips the second item. B. First gets A, third gets C. So destructuring an array is positional. What gets logged? Alrighty. Const items is an array. Const results equals an is the item. So we're taking that array of items and we want to map through it. And we want to take, it looks like each item and multiply it by 2. We then want to take that and filter through and return what looks like what is greater than 3. So this would be 2, which wouldn't be greater than 3. This would be 4, which would be, this would be 6, which would be, so 4 and 6. Chaining works because each method returns a new array. Boop. Alrighty. What does optional chaining do here? So remember, optional chaining doesn't have to happen. But let's see what will. So const user equals null. Bet. And we want to log users preference and theme, but they are optional. So it should just return null. Ooh, I'm wrong. Let's see why. Correct answer C, returns undefined. So undefined. Optional chaining short circuits when it hits a nullish value, null or undefined. Ah, short circuits with nullish values. Instead of throwing type errors cannot read properties of null, it safely returns undefined. Essential for APA data that might not have loaded yet. That is good to know. Yep. That is solid. Alrighty, so optional chaining here. We can't return null, which would equal user, because optional chaining short circuits, which null's values. And since null equals user, that would start with null. No. 9 out of 10, not bad though. Not bad at all. I do think I am going to leave the other game though, just for the Discord group, because it's more of an interactive one. I don't want to just sit here and write code for you guys. It's late, so but all right, that was session 10, erasing objects. The data structure you've been reaching for since day 1, now fully in your toolkit. Arrays versus objects, when to reach for which, destructuring, pulling values out cleanly, spread and rest, copying and merging without mutation, the array methods that actually matter, map, filter, reduce, find, sum, and every, nested data, navigating and transforming the shape of real API responses, immutability, why you never mutate directly, and what to do instead. This stuff compounds. Every session we cover, we're just adding another layer. Like Shrek says, I'm like an onion, to just fit lots of layers. And it's starting to look like, real code now. Not just tutorial code, some real code. So next week, I think we're going to go to async, promises, async, and /await, and fetch. This thing that breaks every junior dev until it suddenly clicks. I know it certainly did for me, and I'm really excited to get into next week. But of course, I'm going to try to still find some more games and things like that to keep you guys entertained and interactive and things like that. So please make sure you keep dropping different comments and things like that to let me know what you'd like to learn about, if you'd like to be in the Discord channel, things like that. So let's see. But yeah, other than that, thank you guys so much for being here. It's the weekly stack, and I'll see you on the next stack.